Hi, this is Steve Gemmel with Earthquake Tech, and today we're taking a video tour of a home in which we have installed these earthquake seismic upgrade anchors in several places, several locations, based on the access. So right now we're going to look at the crawl space behind me. As you can see, we've gotten in here, we've installed the first connection, which connects the foundation to the sill plate with this little curved piece called a UFP, Universal Foundation Plate. And then, most importantly, we've gotten the sill plate attached to the joist system. We had to get creative. Here we used some angle clips that tie into the sill and up into the joist itself to make that connection. We'll put those about every 32 inches based on accessibility again. And if you look further back in, you can see we connected the beam into the pocket that it sits in with a tension tie that prevents the beam from moving back and forth. Connected the beam up to this joist again, all doing a nice job of connecting the foundation on up into what we call the house structure, which really starts with the joist system in these old homes. So if we come out of the the crawl space and take a look up here, we've gone ahead and connected the joists to the beam. Actually, it's more like a header as well. We want to stiffen up anything we can in what we call the floor diaphragm here. We're connecting all the sides of this floor system down to their appropriate foundation walls, which will create a diaphragm. We'll make a diaphragm of the floor, and that will enable the whole house to work together as a unit instead of any one wall having to take on seismic forces alone. So let's take a cut across here over to what we call a full height basement situation. We're using some low profile anchors, foundation anchor plates, FAPs, to connect to the sill, and then every third connection we're going to use the FJA, floor joist anchor, which gets you connected up into the joist system again. Because earthquakes don't just have lateral loads, or they don't create just lateral loads, they also have uplift loads. It's an energy. Energy travels in wave form, so there's going to be an uplift. So we want to keep that house on the foundation by keeping it from popping up. And we continue those connections with these as well, with secondaries here in the form of these angle clips, again, sill plate to the joist system. In the end, what we're doing is creating a system that has enough lateral stability that we get from these beefy flat plates, and then uplift value that we get in combination with these FJAs and these angle clips that connect into the sill joist. Then we run into some interesting stuff here. Typically, this sill plate would just run along and be, just sit in the shape of a rectangular sill plate, but they cut it back at an angle. This is the sill plate cut back. So we now have to create a block to flush this face out and put a plate on after that. So we've got the correct kind of bearing here. We've got to make this a nice flat surface. So if you continue with me here, I'll show you the last connection. So where the house is finished, and we don't want to disturb the interior finishes, we get to it from the outside. by popping off the siding. You can see the siding's popped off. We're just finishing up this length here, and the bottom of these plates will show, but that's all that'll show. If you follow me around to the front, you'll see that we make secondary connections as well that keep the sill plate on connected up to the joist again. So here we have our foundation anchor plate connecting the foundation to the sill plate. Then we go ahead and drill through this sheeting, this old sheeting, into the sill plate and up into the rim joist. There's a rim joist behind here that's part of the joist system and connects those two together to keep the house from shifting off the sill plate. So that's about it for this job. I hope that lends some clarity to the work we do. And of course, you can email us or call us with any questions. Thank you.